Okay, welcome back, everyone. If there is a seat next to you, would you mind trying to scooch up a little bit so that we've got room for latecomers? This is not the biggest room. I would like to welcome Evan Kohilas. Evan's talk is called Args, Amazing or Approaching. Evan is a serial international speaker and engineering productivity advocate who values frictionless simplicity, taming tech debt, thinking in systems, and tightening feedback loops, all to improve the developer experience and achieve nohumanerrors.com. When he's not working on his next talk or project idea, you may catch him as the assistant director of PyCon Australia, tumbling down slopes with a snowboard, chasing frisbees, or defending Subway cookies. Please welcome Evan Kohilas.
Hello, it's great to be here. Are you excited? Yeah, awesome, great. Because I am too, since I have the utmost adoration for Python's beautiful function, argument, and parameter system. Just look at it. Isn't it great? Okay, I'm not that crazy, I think, at least. Anyways, we'll just get the formalities out of the way. Anyone know what the name of these are called? Feel free to shout it out. Sorry? Parameters? Yes, these are called parameters. They are often mistaken for arguments, and I will mistake them in this presentation, so don't fault me. Okay, so what are these? Yes, these are the arguments. Keep that in mind. All right, so now that we've got that out of the way, let's go back to Python's beautiful function argument system that maybe I am a bit crazy for. And to show what I'll mean, I'll start by using a function from another language. And I'll change it up to a more concrete, relatable example, making rectangles. I'll also simplify it down to just a function type signature. And now this function can be called to create a basic rectangle of a particular height and width. But let's say that a basic rectangle isn't good enough, and we've been asked to create a rotated one instead. And to do so, we need to add the rotation parameter. Now we can make a rotated rectangle. But our previous function call now needs to be updated, as it will now error from not having enough arguments. And this creates a problem, because now we need to go through and update all of our previous function calls for any unrotated rectangle and add that additional argument to have it default to 0. And because this is tedious work that we as programmers want to avoid, in most of these languages, there are other ways that a default rotation can be set up. The most basic way is by creating a new function with this rotation parameter. Of course, we don't want to duplicate code that makes these rectangles, and so we can update the old function such that it calls the new function and sets that new parameter with a default argument, which in our case will be 0. Now, if we take a step back, we might start to see how this can get a bit messy, especially if you have all of these argument definitions and they have a bunch of defaults and so forth. The good news is that in some languages, we can do a bit of cleanup through the use of function overloading. With function overloading, we can define multiple functions with the same name, but different type signatures. This removes the need for us to rename any functions, as these programming languages will determine which functions to call using the parameter types instead. If we looked at the same code in Python, it would fail. And this is because in Python, defining a function with the same name overwrites that previous definition. It doesn't work the same way. And while there are packages like Mutable dispatch that you can use to replicate function overloading, in general, it's a bit problematic. And I wouldn't recommend it for reasons that will become more apparent later. So without function overloading, how does Python let us simplify this? Well, in Python, we have default arguments. And these were added back in 1994 for Python 1.0.2. And so what we can do is specify default arguments using this equal sign in the parameter definition. And now, if we only keep a single definition, we can remove the need for this function chaining, and then remove the need to pass in 0, since it will use the default instead. Then we can rename our function back to rectangle to get our beautiful definition. Isn't it great? As a side note, Python is not all sunshine and rainbows either. And honestly, I don't think any language is. And I'll highlight that because of one detail that can be easily missed. Let's say, for example, that we wanted to set a default argument for our rectangles to contain the metadata based on how they were created. And then we added that metadata within the function. What you'll find is that instead of the obvious answer that you'd expect when printing this metadata, instead their metadata ends up being the same. And this is because in Python, the values for these default parameters are created when the function is defined, not when it's called, giving this strange outcome where all of the functions are sharing the same state, which in this case is 300 and 400, instead of 10 and 20. So if your functions need mutable defaults, there is something that you can do. And the best way to do so is to default them to none, and then set the mutable that you want if it hasn't been specified. Now, if we step away from the thunderstorms and lightning, which are very, very frightening, and go back to our original non-Python example, how could defaults be done in a language that doesn't support them? Well, some of you might be familiar with a programming construct called a builder pattern. This is it here. On initiation, it requires and stores all necessary data, and then allows for adding of any optional data before building the final state. But yet, another issue lies with required arguments that even builders can't fix. Can anyone spot the error here? It is a good time for water. So, no one noticed that when I defined this builder, the ordering of height and width was swapped? It should be width and height, not height and width. And in case you're wondering, I have seen this in a code base, so it is possible. And going one step further, the same issue is what can cause function overloading to be harmful. For example, both of these are valid function definitions. The only difference being the ordering of the parameters. But as soon as we remove the rotation of the shape dimensions are now different because that function falls back to the other type definition. Without having to reference the signature of the functions, there's no knowing whether the arguments are set correctly. But in 1995, Python 1.3 did the beautiful thing of adding keyword arguments. You can see here, 2 words, major change. And this lets us choose what argument we wish to fill, and thus lets us solve these issues and do away with builders and function overloading. Meaning that not only are our functions self-documenting by having these constant arguments labeled, which is amazing, but now our argument ordering is redundant. And this might not seem like much, but this little change of always using keyword arguments leads to so many benefits and prevention of errors. Like for example, if we go back to the default argument being used for rotation, then we could call that function with a third argument overriding that default. But once we introduce a new required positional argument like opacity, where 10, 20, and 45 were previously for height, width, and rotation, they're now actually for height, width, and opacity without us ever knowing. Naming our arguments easily lets us prevent this issue, but in addition, also reduces issues with refactoring, such as in the case where we want to fix these misordered parameters. we now don't have to make changes to reorder those arguments wherever that function is called. And if we choose to sort the ordering of the arguments and parameters, we can reduce the chance of merge conflicts. For example, if one commit adds opacity and rotation, and the other adds opacity and color, when they're combined, opacity will be in the same place for both. And even if you don't care about refactoring or collaboration, which I'm sure aren't important, I'd still recommend using keyword arguments to reduce human errors. So pop quiz, can anyone spot the error in this example? And if you already know, give others a chance. It's not easy, right? I'll give you a hint. It's to do with function arguments and parameters. Okay, that's not a fair hint. And that's because there's two problems here. One is that you can't really know this without knowing without actually knowing the function definition off by heart. And the other is that there's all of this complexity around it, right? You have to be like, oh, is the regis correct? What if the replacement function is wrong? What if the strings are in the wrong order, right? And so the real problem here is that the way that read.ignore case is being passed in. And so if we look at the definition, you'll see that it takes in pattern, replacement, string, count flags. And read.ignore case is passed into where the count argument is, not the flags one. And so what happens is flag is read in as an int, and this flag, which is an enum, has the values 0 to whatever. And in this case, it's 2. And so what happens is that the maximum number of substitutions now becomes 2. And so you might be someone like me who's like, why on earth aren't any substitutions working? What's wrong with my code? What's wrong with my replacement function? Like, where on earth is this problem? And then you finally figure it out. In fact, so many people have had this issue that Python has fixed it by introducing a deprecation warning from 3.13, noting that the use of counts and flags as a positional argument will be removed and needs to be used as a keyword instead. And the way that they will do that is by putting star as the parameter before counts and flags. So what is this? What this will do is it will throw an error when we try to call the function without naming those arguments. And we require that we explicitly specify the flag with a keyword argument. And this feature was added in Python 3.0, which is quite a long time ago. So if you are convinced by keyword arguments, and I really hope you are by this point, and you want to ensure that your functions like rectangle are always called with them, what you can do is force that by putting star at the first parameter for all of your functions. But that would require going through and updating the arguments to be keyword arguments, and that can be cumbersome as you can forget, you can make the code noisy, could also require having to go and do that everywhere. Not to mention a bunch of redundant cases where the names of the variables being passed in are the same as the parameters. And while this might look fine, it can get pretty unreadable if you have parameters names that are much longer and many more of them. And a bit error prone. Here's another question. Can you spot the error here? Yes? Yeah? If you're going through a code review very quickly, I bet that you're going to miss this. And in this case, it's the second argument. If you see, it should be y, but it's actually x. The good news is that I'm not the only one who's thought about this. PEP 736 proposes using a trailing equals for arguments that should take from existing variable names in the current scope, which is pretty cool. The bad news is that this was rejected earlier this year. Personally, though, I feel like linters are a cleaner and more pragmatic way not only to check, but also correct this for us. So I'm not too worried. For example, we could have a lint rule that enforces and auto-adds a star on all function definitions. Or if you don't want to do that, maybe a rule that enforces function calls to use keyword arguments wherever possible. Or, if you want the safety without the redundancy, a rule that for this parameter and argument warns when a parameter and argument names don't match. And if that's the intention, you can right-click and do the quick fix to bring clarity with a keyword argument. I would find this so useful. So if mitigating human errors excites you, I'd love to collaborate with you and see how we can better communicate this and create more tools. Or if I've inspired you enough to start using this paradigm in your code day to day, here are some things that might be worth noting. For one, you may notice in your excitement to use keyword arguments for all of your function calls that not all functions are happy with that. And this is because of another special parameter slash, which was added in Python 3.8. When I found out about this, I was like, whoa, that's so recent. It only went out of support last year. And unlike star, which makes all further arguments keyword only, slash prevents all previous parameters from being passed into using keyword arguments. And given the wonders you've seen with keyword arguments, you'd be like, why would you want this? Why is this helpful? Why did they add this? Well, there are 3 cases where I've seen that it is quite useful. The first is apparent if we had to refactor our function and change the name of our parameters. For example, we may want to change the specification and be more specific that rotation should be in degrees and not radians. If we updated the name of our parameter, now any calls that pass in the rotation argument would now fail if they're used as keyword arguments. Thus, by enforcing that a parameter like rotation can only be passed in as a positional argument, this refactoring would no longer be a breaking change. With the trade-off being that our functions now couldn't use keyword arguments anymore. So, there's always a trade-off. Another case is when we want to keep the external argument name the same and change the internal parameter name within our function. And we could do that by setting this parameter to another variable at the top of the function. However, this can become messy. Like the reference to the original parameter is still kept, and you have this header of all of your functions, and there's always room for error. And so this is another case where Python just isn't perfect. If we take a look at other languages like Swift, then this concept of naming parameters different from arguments does exist. Like if we convert our previous Python rectangle example to Swift, then instead of creating a new variable to rename the parameter, an argument label can be used instead that's internal to the function, avoiding the need to change the interface or create additional variables. Wouldn't it be awesome if we could do the same thing in Python? The code would be nice and more readable. It's worth noting that this feature also exists in JavaScript. It looks like this, which is quite similar. But for those of you unfamiliar with JavaScript, the way it works is actually quite different. And the secret is in these braces. And because the braces really define an object, like a Python dictionary, what's really happening here is there's only really one argument being passed into this function. And so the values of the object being passed in are being destructed into the variables width and height, with rotation being reassigned to a different name, which in effect is like assigning the variables from an object individually. Okay, so why am I explaining all this? This is because in the year 2000, Python 1.6 added support for unpacking into function calls, letting us do what JavaScript does with dictionaries too. And by using the double star operator within a function call, Python will unpack the keys of the dictionary as the keywords, the keys of the dictionary as the keywords and the values as the arguments. And this might make you wonder, what happens if extra properties are passed into these function calls? Well, I'm sorry to disappoint you. In JavaScript, the answer is nothing. They don't get unpacked, and thus they're ignored. But there is a way to keep them, and that is by using the ellipsis ... rest property. And this allows us to save the remaining properties for whatever they may be needed for. But if this is how JavaScript name parameters work, what happens in Python if we pass in extra keyword arguments into a Python function? Well, unlike JavaScript, we'll get an error telling us off that we passed in an unexpected keyword argument, which you could argue is pretty good default behavior. And I say default here because you can also specify a way to keep these leftover arguments. And that is by using our good friend double star again, adding it to a rest parameter. And this captures any extra keyword arguments into a dictionary. As a side note, similar to JavaScript, this parameter doesn't have to be called rest either. And the general convention in Python is to use kwargs for keyword arguments, which was also added back in Python 1.3. And unlike JavaScript, Python doesn't currently have a way to unpack parameters within function definitions. But, fun fact, it did used to in Python too. Well, it only really worked if you passed in a tuple and defined the parameters with tuples as well, and then they were unpacked for use within the function. And this was kind of removed because it wasn't getting much use and it was more confusing. But maybe we'll come back to Python 3 differently after a PEP. Anyways, where were we? A question you might have about double star is, what happens if arguments are provided in the function with the double star? Well, Python will nicely tell us that we've made a mistake. And we'll get the same error if they're passed in as positionals instead. And if you did want to make it such that this was okay, there is one thing that you can do. And this is the last of the 3 cases that I mentioned earlier, if you noticed, as another use of slash to enforce these positional arguments. Making it such that those extra keyword arguments are forced into kwargs. And now you might have noticed that kwargs is pretty cool, since it lets us pass in an arbitrary number of arguments. But there are also cases where we can't define a keyword for every argument. For example, if we wanted to sum a list of numbers. Thankfully, back in 1992, this was added as part of Python 0.9.6. And so we can use star args, which is like kwargs, but for positional arguments. Args then appears as a variable that holds a tuple of all of these extra arguments that were passed in. And it's worth noting, by the nature of star args capturing all of these additional positional arguments, that any further parameters must be keyword only. So if a new parameter is added after it, and the function is run as before, we'll get a missing keyword argument error. Unless that argument is passed in as a keyword, and if an extra argument is passed in, then we'll get an error from an unexpected keyword argument. What if we wanted to be sure that we could pass in all arguments? Then we could end the definition with double star kwargs, so that our function captures both. And this would let us pass in all extra arguments down to other functions. And similar to double star, that allows for unpacking within a function call, we can also do the same thing with star, to unpack into functions with variable arguments to respect the shape's function definition. But Are arbitrary keyword opposition arguments a good idea? This is a good question. For that, we can look at the design of safer, newer languages like Rust. And I'm no expert in Rust, and to my best understanding, Rust doesn't support variable function arguments. Not only is it hard for the type checker, but it's also hard for the reader. And so if you do want this complexity, there are two things you can do. You can pass in lists, which doesn't cause these variable type signatures, or macros, which essentially pass that complexity onto the writer to figure out what exactly you want to do. And this complexity is quite evident in Python, since they can make functions difficult to understand, how they should be used, given there's no need for types. For example, like what arguments can be passed into here? I'm sure you've read code like this and you're like, I'm just going to try and find out, right? Even if they are typed in their most simple form, it requires the value to be of the same type, which you could say for the case of args is fine, because if they needed to be typed differently, then in most cases, the definition should be updated with those parameter types. And for typing keyword arguments, only from Python 3.11 were additions added as support to help specify that keywords could be caught and what their types could be. And so to recap, this is Python's beautiful function, argument, and parameter system. The / special parameter marks that the previous parameters are positional only. There's also the standard parameter that can be positional or keyword, and can also be set with a default. As can positional only if they and all other positional arguments are also given defaults. Star captures an arbitrary number of positional arguments and also indicates that further parameters are keyword only, such as this keyword argument or this one with a default. And star can also be used alone as a special parameter to do the same. And finally, double star to handle those arbitrary keyword arguments. And so while we can argue that Python's function argument system is both approaching and amazing, at the least it's forever changing. If you're after the resources for this talk, I've seen everyone take some photos, you can find them in these links. Or if you're after me, you can collaborate with me online on nohumanerrors.com, or find me at Kohilas, or here if you have any questions or feedback. Thank you to my friends, family, and the open source community, as well as to you for listening. Thank you.
Thank you very much, Evan. Here is your mug.
Thank you so much. It's been a pleasure.
We've got about 1 or 2 minutes for questions, if we've got a couple of quick ones. We've got one right up the back here.
What do you think about using new type to type things like height and width? So you have like a width new type and a height new type, instead of just using ints to improve type safety?
That's a good question. That's a complex question. Let's talk after this.
All right. Well, I know that Rough does have some rules for detecting positional Boolean parameters, which definitely ties into this talk, but not for other types of parameters.
Yes, a lot of these, Rough does have some, but majority of these rely on the linter knowing what the definition looks like. And Rough doesn't support that yet. It's on their roadmap, but it essentially requires like integrating in TY and all of that. So as soon as they do that, that's the first thing I'm going to do. But until then, you can use linters like PyLint, I think, which has access to that. But then you also have the problem that it's a bit slower. So yeah.
Cool. Thank you again, Evan. Another round of applause for Evan, please.
Thank you so much.